Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will go to the introduction of our project that is voltage path reflection. So among the various techniques available, the VPR voltage path reflection method stand out as an effective approach for accurately locating fault. By leveraging the principle of wave propagation and reflection, the VPR method provides a reliable and efficient means of identifying fault location with high precision. This technique is particularly valuable in complex electrical network where quick and accurate fault detection is paramount to ensure continuous operation and safety. Through this method, engineers can not only detect the presence of a fault but also pinpoint its exact location, enabling timely and targeted maintenance intervention.
Now, let me explain about the three types of fault, which one is open circuit fault, which is a fault that caused by a break in the cable conductor. To detect this, we could use a mega. This will show zero resistance for a good conductor and infinite resistance for broken conductor. Next is short circuit fault, which caused by two conductors of a multi-core conductor that had a contact. Also, by using a mega, we could detect the fault by connecting the two terminals with any two conductors. A zero reading indicates a short circuit fault. The last one is earth circuit fault, which is caused by a conductor is in contact with the earth. This can be detected also by connecting the mega to conductor and earth. If the reading is zero, it means the conductor is showing the earth circuit fault.
So for the next slide, I will explain about difficulty to locate exact location of fault. So there are three causes that make us difficult to locate the fault. First is signal attenuation and noise. As the voltage path travels along the conductor, it can weaken and pick up noise from external sources. This can distort the reflected signal, making it harder to accurately interpret and locate the fault. Second, multiple reflection. In complex network with numerous branch and component, the initial pass can produce multiple reflection. This reflection can interfere with each other, complicating the identification of the fault reflection among the various signal. And lastly, impedance variation. Variation in impedance of the conductors and connection can affect the reflection characteristic of the path. Non-uniform impedance can cause reflection even in the absence of a fault. This will lead us to false positive or incorrect fault location estimate.
So what is Varley loop test? It is a traditional effective technique used to precisely locate faults in underground electricity distribution cables. It relies on electrical measurement and principle of circuit analysis to pinpoint faults such as open circuit, short circuit, and earth faults within the cable network. There are two circuits. First is value loop test for earth fault, and then the second one is value loop test for short circuit fault. You can see the difference at the bottom. And then for your information, Varley loop test is also for locating short circuit and earth faults in underground cables. And then this test employs the principle of Wheatstone bridge. Let's discuss the principle of Varley loop test. To perform Varley loop test, connections are done as shown in the circuit. So R1 and R2 are fixed, and then resistor S is variable. So if the switch K is first thrown to the position 1, and then the variable S is varied till the galvanometer shows 0. Zero reflection means the bridge is balanced. Let's say the bridge is balanced for the value of S equal to S1, then R1 plus R2 is equal to Rg plus Ry over Rx plus S1. So we let Rg plus Ry is equal to R3, and so we substitute the value R1 plus R2 over R2 is equal R3 plus Rx plus S1 over Rx plus S1. And then we arrange Rx plus S1 equal to R2 open bracket R3 plus Rx plus S1 close bracket over R1 plus R2. So simplify, we get Rx is equal to R2 open bracket R3 plus Rx close bracket minus R1 S1 over R1 plus R2 as the first equation. Now the switch K is thrown to the position 2 and the bridge is balanced by varying the resistor S. Say the bridge is balanced at the value of resistor S is equal to S2, then R1 plus R1 over R2 is equal to R3 plus Rx over S2. We arrange R1 R1 S2 is equal to R2 open bracket R3 plus Rx close bracket as the second equation. Now putting the result of equation 2 and equation 1, we get Rx is equal to R1 open bracket S1 S2 minus S1 close bracket over R1 plus R2. Since the values of R1, R2, S1 and S2 are known, Rs can be calculated. When Rx is known, the distance from the test end to the fault point Ls can be calculated as Rx over R. R is a resistance of the cable per meter.
Now, let's see about the advantage and disadvantage of Varley loop test. The method had good fault localization, which we can locate the fault by comparing the resistance, despite relying on the cable length itself. The next one is the Varley loop test is suitable for high fault resistance that can maintain the sensitivity. And the last one is the Varley loop test can be used to locate two faults, which is short circuit fault and the earth circuit fault. For the disadvantage, the Varley loop test requires uniform cable section, which means any temperature effects will lower the accuracy for the test currents. The next one, I take a Murray loop test as a comparison, which is the Varley loop test is more complex than Murray loop test because of in order to balance the Whetstone bridge in the Varley loop test, the circuit need a variable resistor. And the last one is the Varley loop test is generally preferred for shorter cable as compared to Murray loop test, which is commonly used for longer cables.
Let's see other methods, which is voltage pulse reflection. This method is a high voltage radar technique used to locate faults in the underground electrical cables, especially for class cables where the fault requires a higher breakdown voltage than a typical dumper or surge generator can provide. So this method uses a voltage coupler. Second, dielectric test set, which is high voltage DC test set or probe tester, and lastly, storage oscilloscope for analyzer. So the voltage coupler senses the reflection that produced when the DC voltage from the dielectric test set causes a flashover at the cable fault. So the storage oscilloscope captures and displays this reflection, allowing the location of the fault to be determined. So this figure illustrates the voltage pulse reflection. So how the voltage pulse reflection operates? First, the dielectric test set applies a high DC voltage which is greater than the breakdown voltage at the fault to the cable under test. Second, when the voltage is high enough, it causes a flashover or breakdown at the fault location, creating a momentary short circuit. So the short circuit produces a voltage reflection that travels back towards the test equipment. The voltage coupler senses these voltage reflections and send the signal to the storage oscilloscope. So this method use the formula multiple reflection, which is R equal to ZF. ZF is the fault impedance minus Z naught, the characteristic impedance of the cable over ZF plus Z naught. And then lastly, the oscilloscope captures and displays the reflected voltage waveform, which is on the computer, allowing the distance to the fault to be calculated based on the time of based on the time of light.
Okay, next we will move to the advantages and disadvantages of using voltage pulse reflection. So for the first advantage is high accuracy. This voltage pulse reflection provide precise fault location by measuring the time delay of the reflected pulse. This allow for accurate identification of the fault position. Next is non-destructive testing. So this method does not require any physical alteration or damage to the system, and is making a non-invasive and safe approach for diagnosing fault. And lastly, for the advantage, cost effective. It can be more cost effective compared to other complex diagnostic method, as it often require less specialized equipment and can be performed relatively quickly. And for the disadvantage, the first one is complex interpretation. The presence of multiple reflection and impedance variation can complicate the interpretation of the reflected signal. This requiring expertise and experience. And next is environmental sensitivity. External factors such as temperature and humidity can affect the accuracy of the method, as they can alter the electrical properties of the materials. And lastly, the limited to electrical conductor. So this method is primarily applicable to electrical conductors and may not be suitable for other type of system or material other than this.
In conclusion, most of the test is a good method to locate the exact fault location for underground cable based on each function. For Varley loop test, is a good method to locate short circuit fault and earth fault in underground cables. It have a good fault localization, suitable for high fault resistance, and detects variety of faults. But it needs uniform cable sections. Complexity it also complex with a variable resistors, and it commonly used for shorter cable. While for the voltage pulse reflection, it was used to locate open circuit fault, short circuit fault, and insulation breakdowns. This method is a good which it have high accuracy, non-destructive testing, and cost effective. But this method also complex because of the multifold reflection, and it also sensitive to the change in the environment, and it also limited to electrical conductors. To compare both of these methods, it has its own pros and cons, which depends on how and where to detect the fault. For Varley loop test, it's ideal for simpler, low-cost application where high accuracy is required and the condition allow for the use of reference cables. Voltage per reflection is better suited for situations requiring fast fault location, especially in complex networks, or where non-intrusive testing is beneficial. So that's all from us. Thank you.